about triangles, okay? So when we talked about triangles last week, what were the ways we can identify a triangle by its sides? No, that's not what I'm asking. There's isosceles, scalene, what's the third one? Equilateral. That's by the sides. What about the angles? Obtuse, acute, and right. Okay? Now, we also had to solve for the angles inside a triangle. Okay? So, if I had this triangle right here, right, what do we say the inside angles, the interior angles equal? They always equal 180 degrees. So if I had this problem right here, what would I do? Yeah, just 75 plus 64 and subtract that from 180. Okay? Now, today, we're going to be talking about exterior angles. Okay? So it's going to look like an angle on the outside. Okay? So before we kind of look at this, all right, let's look at just trying to get a white page. Okay? Now, when we have a triangle, okay, we said the interior angles equal what? 180, okay? Now, with an exterior angle, that's when one of the sides, so if I have this line, can you see that red dot? Okay, it extends and comes out, okay, creating an angle right here. Okay, do you see that angle? Okay, so that's what that exterior angle is going to be. Now, when we solve for exterior angles, okay, there's a certain way that we can solve. So, first of all, if I have this triangle, all right, and this is the exterior angle, all right, what do we think if we had to solve for this angle right here? What could we say about these two angles? They're not congruent, but this is something we have talked about. No?
What is it?
What can we say about these two angles?
They must equal 180 degrees.
They add up to equal 180 because they're what?
A linear pair.
They are a linear pair, but no. They're a linear pair, but what was the word when two angles add up to equal 180? Supplementary. Okay? Okay, so these two angles would be supplementary. So they add up to equal what? 180 degrees. So if I had, okay, let's say I had a triangle that's like this, and this angle is 130 degrees, what would this angle on the inside be? It would be 50 because they add up to equal 180. Okay? Now, let's say, what if, I'm going to erase this one. What if I had a triangle, okay? I have this triangle, okay? And let's say I want to find the exterior angle. This angle right here is 40. This angle right here is 50, okay? How can I find the exterior angle from here? Okay, you could do that. Or what's nice is if I draw that same triangle and label the angles with numbers. Okay, this is a 2. All right. All of these are interior angles, 1, 2, and 3. Okay, 4 is our exterior angle. Well, what's nice is angle 4, our exterior angle, equals our remote interior angles. Okay, so that means angle 4 equals angle 1 plus angle 2. Okay, the remote interior angles are the angles that are not sharing a side with the exterior. So that's going to be these two angles right here. Okay, so all I would have to do on this example is just add 40 plus 50, and that gives me the exterior. Now I know that equals 90 and doesn't look like a right angle, but if I had a different example like this one, all right, let's say the exterior angle is this one, all right, and this is 36 and this is 72. All right, how would I solve for the exterior angle? Just add them together, yeah. So what's 36 plus 72? 108. So that would be my exterior angle. Okay, do we see how we did that? All right. No. That's not all we're going over today. Okay, I'm going to zoom out. Okay, and let's look at some examples. So this one right here, all right, it says, I need to find the value of x and my exterior angle equals 78. Okay, how am I going to solve for x? What do we say about these two angles? They're supplementary, so they do what? Yeah, so what am I going to do to solve? No. No.
180
Just 180 minus 78. Because remember, these two are supplementary. They just add up to 180. So what's 180 minus 78? So that's the angle right here. So do we need to know anything about 23? 23 doesn't help us with anything. It's kind of throwing us off there, right? So our value is just 102 degrees, right there. Kind of. What about this one? How do we solve this one? X. What do we say about these two angles? They add up to equal the exterior angle. So we can just do x plus, what's the value of this angle? Equals 126. So how do I get x by itself? I subtract the 90. So what's 126 minus 90? And there's x. No, it's not too bad, right? Pretty easy. Okay. Eventually we'll see some word problems of these. All right, what about this one? Again, this is just like the last one. 53 plus x equals 72. What do I do to get x by itself? Subtract 53. What's 72 minus 53? 19 degrees. Okay, do we have any questions about exterior right now? All right, go ahead. No. Oh, that's as big as it gets. Let me do something. Let's do number 6 and 7 on your own. This is 132. This is 129. 15. Yep. Right, you can just do 6 and 7. All right, so what do we get for 6? X equals what? 42. Because you can just do 132 minus 90. What about 17? Or no, yeah, 7. 114. Because you do 129 minus 15. Okay? Do we have questions about exterior angles? No. Okay, we're going to move on to the next part. Okay, I'm going to zoom into some white again. Okay. Now we're going to talk about the inequalities of a triangle. All right, go ahead and close it, Austin. You don't need it out. Okay, when we're talking about the inequalities of a triangle, okay, we're just going to be given numbers. All right, something like this. All right, and we have to tell if these three numbers, which are going to represent the sides of a triangle, if they can make a triangle. Okay, so we are given just three numbers, and by those three numbers, we can tell if it is a triangle or not. Okay, so let's go ahead and look at this. Now, what we're going to be doing is we're going to be given three numbers. Okay, we always need to pay attention to what are the two smaller numbers and what's the largest number. So in this one, what's my largest number? 7, okay? So that's going to be my largest. Now, what we're going to do is when you have the two smaller numbers, you have to add them together. So what my two smaller numbers are what? 4 and 2. So what is 2 plus 4? 6. Okay? So we have 6 and then we have 7. Okay? In order for this to be a triangle, the two smaller numbers have to add up to be greater than the third number. Would this be a triangle? No, this would not be a triangle. Now let's look at another example. What if I had this? Okay, I have 11, 12, and 18. All right, so 11, we need to add the two smaller numbers together. What are the two smaller ones? 11 plus 12 is 23 greater than 18. Yes, so this is a triangle. That's it with these. Okay, now real quick, what if I had this? 9, 13, and 22. Let's add our two smaller. What's 9 plus 13? 9 plus 13 equals 22. Is 22 greater than 22? It's not greater. So is this a triangle? No, it has to be greater. So let's look at some examples. This one, okay, number 11, pay attention because this is the part that gets everyone. Which of the following sets of numbers could not represent a triangle? So you'll have ones that will say could represent or could not. Okay? Well, let's look at A. 5, 16, and 20. All right? We add our two smaller ones. Is 5 plus 16, what's that? Is that greater than 20? So this could. B, 9 plus 16, what's that? Is 25 greater than 25? No. So that would be our answer. Okay? Go ahead. If I can get this to work, sorry. There we go. Do number 12, 14, and 15. Do 12, 14, and 15 on your own. Twelve, 14, and 15. All right, on number 12, what do we get?
A.
Perfect, A, because that could not. 14 also says could not. Which one is our answer? D, cannot. Finally, on 15, it says which one could. And that is A. Okay, so pay attention. That's where everyone misses it. Anyone have any questions on those? All right, we got one last one to look at. There's nothing. Okay. This is called angle-side relationship. Okay. So we are given a triangle. All right. And let's say that we have the sides of this triangle are 5, 6, and 7. Now, do we know anything about the angles? No, but based on this triangle, we can figure out what angle is going to be the largest and which one's going to be the smallest. Okay, and which one's going to be in between. So if we look at this triangle right here, okay, we need to identify our sides, okay? So what side is going to be my smallest side? 5. And can you name that side? AB. Now, if we needed to find the smallest angle, we go directly opposite from the smallest side. So see how AB is my smallest side? I'm going to go directly opposite. And what's my angle that's directly opposite? Angle. Angle, no, angle. C.
Or angle C.
Yeah, you don't have to name it BCA. You can just name it angle C. Angle C would be our smallest because it's directly opposite from the smallest side. Which one would be my largest then? We need to identify the largest side. Which side's the largest? BC is the largest, so I go directly opposite. Angle A is my largest. Okay, so which angle would be in the middle? Angle B would be in the middle. Okay, do we see that? Let's look at this. What if I had... Do this on your own. Tell me from largest, mark your angles from largest to smallest. Go directly opposite from those sides. I said, yep, largest to smallest here. Just the middle. Okay, just put them in order. That's what I want. Largest to smallest. Okay. What angle do we get as our largest? Say it together. Do we all get S? What's our middle one? Smallest? Okay. Now, we did that with sides. We can do the same exact thing with angles. All right, let's say this angle is 40. This angle is 60. This angle is 80. Now, we can do the same exact thing here. Now, I want to name from this time smallest to largest. Okay? What's my smallest angle? 40. To find my smallest side, I go directly opposite. What's my smallest side? BC. You gotta make sure you name it BC. What would be my middle side? AC, because you go directly opposite. Go directly opposite from the largest angle. What's my largest side? AB. Okay? Let's look at some examples with these. Go ahead. Do Just do 23 and 26. Just do 23 and 26. Now, there's that many options because like that's all the different ways that you could do it on your orders. So that's why there's so many options. But you guys can figure this out. 23 and 26. I would recommend whenever you do these, draw the triangles. So I drew this triangle. It's triangle STU. It says TU is 7, US is 15, ST is 10. And you got to figure out which statement is true. The measure of. What? So this, like A, if we looked at A, it says the measure of angle T is greater than the measure of angle U, and that's greater than the measure of angle S. So really, this is like largest to smallest.
Would that be all of it? Would that be all of them?
That would be for all of them. So if you look at A, no, never mind.
Yeah, that's because it is.
Yeah.
A.
It is A. Because T is the largest, because it's across from 15. U is the second, across from 10. S is across from 7. Okay, do number 26. Now, it only gives you 2 angles. How do you figure out what the third angle is? No. You can add them together and subtract it from 180. Then you're going to tell me what the answer is to this one. Mm-hmm.
On the test, what we have to do.
What does it say? It would not be on there. But you can draw it. You just have to read it. It tells you what the triangle is, so just make a triangle and mark those corners from this. Got your answer? What'd you get, Austin? Shortest to longest.
Really?
It's not. It's not E. Yeah. Okay. Because you go directly opposite from the smallest. So QR is our smallest, directly opposite to the largest. RPR is the largest, or RP. Okay. Do we see that now? Okay. That's all we're going over today. Now, just a heads up. Tomorrow we have 30-minute classes, okay? So, no. So tomorrow we're going to go over isosceles triangles and solving those, okay? Because it's the Advent service.